Quantum theory focuses on the world of the infinitesimally small, but at about the same time that it was being developed, another theory was being formulated that explained large-scale phenomena. This theory was mostly developed by one man, Albert Einstein, and is called the theory of relativity. Many feel that it was the most important development in 20th century physics. Einstein developed his theory in two stages. The special theory of relativity was published in 1905, when he was only 26 years old. Special relativity links space and time into what Einstein called the space-time continuum. The three dimensions of geometry are length, width, and height, which give the coordinates of any position relative to a reference point. Einstein added the fourth dimension of time, because all events happen at some position at some time. This is not such a weird concept. The football player has to be not only at the right spot, but he must also be there at precisely the right time in order to catch the ball. He is operating in a four-dimensional world. Einstein believed that the motion of everything in the universe was relative, except for one thing, the speed of light in a vacuum. He came to a number of startling conclusions about space-time and the speed of light. His mathematical calculations determined that the faster an object moves, the more its mass increases, and in turn, it takes more and more energy to accelerate the object. As it approaches the speed of light, the object's mass approaches infinity, and it would take an infinite amount of energy to move it. Plus, time would come to a halt. Since this is impossible, Einstein concluded that light is the only thing that can travel at this speed. But the most startling conclusion reached by Einstein is that energy and mass are linked with the speed of light in E equals mc squared. E is energy, m stands for mass, c squared represents the speed of light times itself. What the formula says is that mass and energy are interchangeable, and because the speed of light is such an incredibly large number, a small amount of mass can be converted into an enormous amount of energy. The nuclear reactions in the sun are an example of the conversion of matter into energy. This is called fusion, and we have even learned to use the formula to convert matter into energy ourselves. The energy released by nuclear reactors and nuclear bombs are based on the formula E equals mc squared. It is called fission, the splitting of the atom. Einstein lived to see the nuclear age, and like the rest of us, it left him with a sense of both awe and fear. Einstein continued to work on relativity, and in 1915 he published his general theory of relativity, which deals with the effect of gravity on space-time. Newtonian theory holds that a planet circles the sun because of the attraction of the mass of the objects, but Einstein said that was not what was happening. General relativity holds that the mass of a huge object, like the sun, distorts the space-time around it. In effect, the mass curves or warps the space-time around the sun into what is called a geodesic. A planet orbiting the sun travels in a straight line, following the geodesic shape, and orbits the sun. Einstein's revolutionary ideas have not only changed our understanding of energy and matter, but his general theory of relativity has made a major contribution in our understanding of the universe and its origins.